All right, this video will go over the chapter 4-5 final review packets. Identify each statement as true or false. This says two sides and a non-included angle of one triangle are congruent to two sides and non-included angle of another triangle, and the triangles are congruent. This is false. The reason for that would be because if you have triangle and two sides and the non-included angle, and that would be SSA, and so that's going to be false. Next is given two angles and an included side. You can construct exactly one triangle, and that is going to be true. And so let's say I have this is gone, this is gone. So if I have two angles and an included side, that's going to be ASA, which is a shortcut, so that's going to be true. The sum of the measures of an interior angles of an octagon is 1,440. That's false because the equation for that is an octagon is 8 sides, and it's 8 minus 2 times 180, which is 1,080. Another way to think about it is that in an octagon, it's going to have 6 triangles inside of it if you divide it up. And so 6 triangles, each triangle has 180 degrees. 6 times 180 is 1,080. Right, so I'm going to illustrate that with a pentagon. So if I divide it into triangles, then your pentagon's going to have 1, 2, 3 triangles. So that's 3 triangles. Each triangle is 180 degrees, which will give you 540 degrees in a pentagon. Similar with that one. Diagonals of an isosceles trapezoid are congruent. That is true. It is possible to create a triangle with 12, 7, 5. Well, 5 plus 7 equals 12. It has to be greater than 12 to create a triangle, so that's going to be false. Opposite angles are congruent, so that's false. A diagonal of a square divides it into 2 equilateral triangles, and that is it says true, but I don't think it is. Let's see. So you have a square, and if you divide it, oh yeah, now these are all the same, right? But the diagonal is longer, and so it divides into 2 isosceles triangles, not equilateral triangles. So this should actually be false. That should be false. Okay. Opposite angles of a quadrilateral inscribed in a circle are congruent. And it's true with a question mark and a crossed off. Well, it's not shouldn't be crossed off. It's definitely fair game. And let's go ahead and take off this question mark here. Let's go ahead and solve this, shall we? So we need a circle, first of all. And then we need a quadrilateral inscribed inside of it. 1, 2, 3, 4. Oh, let's not do that. Okay. So it says opposite angles are congruent to each other. Well, I can tell you right now that these angles definitely don't look congruent to each other. So no, I could see myself easily making a quadrilateral. Like if I have another circle here and I do maybe something like this, right? And then a side way over here, and you look at this, there's no way opposite angles are congruent to each other. So yeah, this should be false, not true. Okay. Diagonals of a kite bisect each other is false because in a kite, only one of the diagonals is bisected. Let me do a better kite here. Well, anyway. So in a kite, this longer diagonal does bisect this one, but the vertical diagonal doesn't bisect the horizontal diagonal. So the key is each other. So that's going to be false. In a equilateral triangle, the bisector of an angle is also the altitude to the opposite side of the angle. All right, so in an equilateral triangle, the bisector of an angle is also the altitude to the opposite side of the angle, and that is true. Yes, so in an equilateral triangle, so all sides are congruent to each other, this the bisector of this angle is indeed the altitude. In other words, it is perpendicular to the base, so it is the height. That is true. So if an opposite angle, I'll point up to this one to indicate that's what it stands for. If an opposite angle, parallelogram, okay. If an opposite angles of a parallelogram are supplementary, then the parallelogram is a rectangle. Well, that would be true because opposite angles of a parallelogram are congruent, right? So if they're congruent and supplementary, they would both have to be 90 to be supplementary and congruent, wouldn't they? So yeah, it would have to be a rectangle. That would make sense. Okay. Very good. Next, part B. In a regular pentagon, each interior angle has a measure of 108 degrees. That is because, and I think I showed you that before, 1, 2, 3, 4, 5. Oh, that's, hold on. Okay, so in a pentagon, what you can do is divide it into triangles. So I have 1, 2, 3 triangles. Each triangle is 180 degrees. So you go 180 times 3, right? But if it's a regular one, that means that all of the angles are congruent. So if you divide by 5, you're going to get each angle being 108 degrees. And that is what they'll each measure. So, number 2, if one of the base angles of an isosceles triangle has a measure of 40 degrees and the vertex angle is 100, well, that's going to be true. It's going to be 100 degrees because if it's isosceles, the base angles are congruent. If the base angles are both 40, that's 80, making this one would have to be 100. There you go. And in triangle ABC, I'll actually go back up here and mark them all congruent to each other. In triangle ABC, if A is 50, B is 72, and C is 58, I'll just cover that real quick. Yep. Then AC is the longest side. Let's see here. Actually imagine, if you can imagine, that's not realistic. I'll go over here. So one of them is 72, one of them is 58, and one of them is 50. So that would make, this probably is B. Let's make this C and this A. Okay. The longest side is going to be opposite the longest angle, which would be side AC. And in a regular n-gon, each exterior angle has a measure of 180 minus 360 over n. And that is a typo. So let's change that, shall we? So that's going to be 360 divided by n. Okay. Reason for that is because in a do a better job getting done. Oh, come on. 1, 2, 3, 4, 5. Oh, that's because ink to shape is turned off. There we go. Okay. So if you have a regular n-gon, that means that all the sides are congruent and all the angles are congruent to each other. That's what makes it regular. And the exterior angles are these right here. And so if we take all these angles and we add them up, they're all going to make up a complete circle, right? So they'll all be a complete circle, which, as you know, is 360 degrees. If it's a regular n-gon, that's going to make these also be all congruent to each other as well, because they're each a linear pair with the same angle. And so we'll just take 360, divide it by the number of angles, which is 5, or in this case, n. So it'll be 360 over n. Okay. If the mid-segment of a trapezoid has a length of 6 centimeters and one of the bases has a length of 4 centimeters and the other base has length. So this is crossed off, but it shouldn't be. It is definitely fair game on the final. And so let's go ahead and draw a picture of what this might look like. So you have there we go. So you have a trapezoid, and it has one of the bases is 4. This one will be 4. And then your mid segment is 6, and I'll just call this X, right? This is your mid segment. It's also parallel to the two bases. Okay. So how does that work? Well, it turns out that 4 plus X, if you add that together and divide by 2, and that is going to equal 6. Another way to think about it is that 4 plus X equals 6 times 2, or 12. And so since 4 plus X equals 12, X would have to be 8. And so that's going to be 8 centimeters. Okay. Next is, I'm going to go ahead and erase this over here. Okay. Next is 2 diagonals of a square perpendicular bisectors of each other are congruent and bisect the angles, right? So these are properties. If they're perpendicular bisectors of each other, that's the properties of a rhombus. And the fact they're congruent is the property of a rectangle. The fact that they bisect the angles meaning opposite angles. So for example, if you have this shape, then the diagonals are going to bisect these angles right here. That's what it means by bisect the angles. That's the property of a rhombus. And as you know, a square has the properties of a rhombus and a rectangle, so that's why it's a square. Okay. There we go. So here's some questions here. Hexago is a regular hexagon, and it asks you to find P and 60, and P and Q and R. Okay. So if it's a regular hexagon, that's going to mean that all the sides are congruent, all the angles are congruent, and so that's going to be, so P is going to be 180, and we can divide that up into 4 triangles, or 180, 6 minus 2 is 4, divided by the number of angles, and that's going to give me 120 degrees. R is then going to be 180 minus 120, right? Because this angle right here is 120. And then we know this angle here is also R because you have an isosceles triangle there. And so that's going to make it 60. So 60 divided by 2, which is 30. So that's why R is 30. And then Q is going to be, well, if this angle here is 120, Q would have to be 60 because it's a linear pair with that angle. So that makes that 60. Okay. Rhomb is a rhombus, meaning it bisects the opposite angles and is perpendicular. And right, these are the same too. Okay. So A is going to be what? Well, if this is 90 and this over here is 60, because this is 60, and I would have to make A 30 for all the angles in that triangle to add to 180. B then is 90, because all of these are right angles right in here. C is going to be 60 because it's congruent to this angle right here, right? These are congruent angles. That's 60. D is going to be 13 because these diagonals bisect each other, so D will be 13 inches. And we're done. In 3, it looks like we have an isosceles triangle. And then this is, it bisects the top angle, which is, remember, that means also the altitude. And it's also the going to hit, to divide that in half as well. It's also a median. And so that's going to make W be 14 because this is also 7. And X is going to be, well, before we find X, let's find Z first. So this is 25. This is 25. And this is 90. Adds to 180. That would have to make this 65 degrees. And since isosceles, the base angles are congruent, this is also 65 right here. And with the linear pair, that would make that 115. And Y would have to be 90 because this is a bisector of an isosceles triangle. If you bisect the vertex angle, this will always be the altitude, so always perpendicular. That makes that 90. All right. Well, there we go. That is that problem. So part D, proof. Flowchart proof says to provide the missing reason or statement in the flowchart proof. So it looks like in this problem we need to show that two triangles are congruent, and then that will give us that these are congruent. We have two givens and then a third box for vertical angles. So let's figure out what we got here. So usually when I have a problem like this, I like to mark what I'm given, which is what they did here. So C and N are congruent. These are congruent right here. And then it says 1 is congruent to angle 2 down in the proof right here. So that's going to mean that 1 is congruent to 2. We need to show that OY is congruent to KY, right? So again, one of the ways to do a proof is to work backwards. If we need to show that OY is congruent to KY, then we can do that by showing that this triangle is congruent to this triangle. I think. Let me just. There we go. All right, so show they're congruent. Now they're not because I didn't draw them quite right, but so this is C, Y, O, and this is K, Y, N. Uppercase N. Okay. So we're given that these are congruent, because of vertical angles. These are congruent. Okay. So we need to show they're congruent. We can do that by angle side angle, looks like. And we're given these two, these aside, and we're given this angle. And so that's why they write given below there. These are congruent because they're vertical angles. And then OCY is congruent to KNY, and that's because of angle side angle, which means that OY, this side, is congruent to that side because the triangles are congruent, which we say is the corresponding parts of congruent triangles are congruent, or CPCTC. And that's the flowchart proof.